as we go through this graphing, we may be doing it 100% like you have done the graphing before. When you have graphed parent functions before, did you find a table of values to help you graph it? Yes or no? Yes or no? Yes? Okay, maybe? No? Maybe? All right, so we're not doing a table of values today. There's a different approach to this. I'm not saying that this you did it wrong. I'm not saying that we will get there. We will need a table of values. That's just not how we're doing it today. Okay, we have to have many tools in our toolbox, right? So we're going to start with, here's this function number 1. The first thing we have to do is decide what's the name of the parent function that goes with that. Absolute value. So we're going to write value. Then the parent function, since this is f of x, we will use g of x. And that's equal to absolute value of x. It's okay. It's why we use pencil. It's forgiving. And if at any point when you're graphing or doing anything, that's what you should be using pencil. The colored pencils in your supply box are erasable, so they're forgivable too. And if you need to go get sharpeners for them or whatever, you can use that. All right. So then we're also going to do a little sketch what the absolute value function looks like. All right. Let me see your best absolute value. To be a function. So everybody be a function. Come on, Chris. Come on, Cedric. Let me see your absolute value. You can do it. All right. All right. Caitlin, we're waiting on you. There you go. Thank you very much. Okay. All right. All right. If you had put it down and you did it, I'm good. All right. So we're absolute value, right? We're all good? Yeah. This box, we're doing pretty much what we did yesterday. List out what the transformations are. We start with the negative right there. So that means we're going to reflect some, right? What are we going to reflect in? The x-axis. Then that's the multiplication type of thing I have in there. So the okay, right, 1 and 7 up. It's fine to put the 7 first, and up 7, not 7 up. Right, 1 and up 7. That's okay. No. All right, so then now when we go to graph these, here's what we're going to do. What I kind of would really like to happen, but I'm not going to have you do it, is for you to lightly sketch the parent function in the background. But unfortunately, not everybody understands what lightly sketch means, and then it's just as dark as the rest, then you confuse yourself. So we're not going to go down that road because it's just going to make it worse for some of you. But what we are going to do is we are going to put the anchor points on there, but not as points, okay? And this may seem a little silly, but eventually once you've got the hang of the graphing, you don't have to do this part anymore. But I want you to all start this way just because even if you feel comfortable with it, sometimes it's easy still just to choose the wrong point. So it's just kind of for us to get the hang of what I'm even trying to get you to do. So our anchor points, we're going to put as little stars so that they don't look like actual points. Now, if you have issues with, some people just can't draw a star like that to save their life, it doesn't have to be pretty. Triangle, that's fine too, or a little asterisk, just something so it's obviously not a point. You with on that? All right, so our anchor points are 0. One. Those are things that we need. They're not part of our final function. The rest of it, because those are really just those points will help us get it. As long as like that's why this is important too. Then what we do take each one of those requires doing it 5 times, but we're going to take each one of the information. So I'm going to start with 0, 0, because that's the easiest one. I'm going to reflect it in the x-axis so I can know it, right? And then I'm going to up 7. 6, 7. My vertex. Me? Okay, yeah, this is an actual point. I start with this one, 1, 1. So I'm going to reflect it in the x-axis, which means this goes here. Then I translate and up. This function did these 2 points right here. This one here. Makes sense? I don't have to actually count or anything. I just know how that works. This point right here, I'm going to reflect it in the x-axis right here. It's like 2, 3, 4. You understood come up with that. I just want to have that. Or you can count it if you're unsure. Don't feel comfortable that you mind wrapped around it, right? This requires actual lines or rays here. You need to use this your ID badge. It's a great draw that in. I realize that some of the graphs they have arrows, okay, but when you draw them, they better. If they're supposed to have arrows, they better have arrows. Otherwise, you're not drawing it as accurate. At this point. So domain. Our domain. The domain of the parent as well. Yeah. Range. I start at negative infinity. Do I include the 7? Yes. Is that the same range as the parent function? No. Shift up is what changes and it negative. Yes. Get and actually One, 2, 3, 4, 5.5. Is this of this. This one is would be 1. Okay, so if I totally missed one, it's not a guess off the graph. That's me using my knowledge of the function to know exactly where that x-intercept is, right? And if I could actually erase this easily, then I might redraw my line, but I'm not going to worry about it. So something 1. How don't hit your point in the middle, it doesn't come out clearly. So there are your difference in guessing off the graph. So that gives me a 0. No. Do I exactly what my y-intercept is? Yes, that's the point, and that is 0, what? 6. Do I fix to what? To 1. And then my behavior as x approaches infinity, f of x approaches infinity. X approaches infinity. And as x infinity. Quadratic. Equals x. Good, good, good. Our parabolas and others. So I'm judging. All right, so quadratic. How many transformations are happening here? Just one, right? And is that going to affect me horizontally or vertically? Horizontally. Okay, So this is going to be a horizontal what? Stretch. Factor of 4. Agree with that? X lies, right? Does it make a little more sense what X lies now? Okay, good. All right, so we're going to points 0 to 4. Okay. We don't. I'm going to say 0, 0. Horizontal stretch of 0, so it's not very exciting. It's right there. Then I go to 1, 1. This is a horizontal stretch, so my x value, which is 1, gets multiplied by 4. So my x value becomes what? 4. It's not like 4 more. It's from 1 to 4. Does that make sense? So it's right. So I can put another point over here. Using that symmetry, be careful that you have your side because it's easy to set up. All right, so comment 2, 4. My x value changes by a factor of 4. So what's my new value? 8. And then I'm still at 4. My y value stays the same. And there's your parabola that's been. Okay. Domain to infinity. Change where I start. 0. Okay. So those are. Is that the same as the parent function? Yes. What's my x-intercept? 0, 0. Y-intercept? Okay. Absolute min. Good. And that's also 0, 0. There. Same as the parent function. F of x approaches. Okay. So for discontinuity. The extrema is an actual point, but the continuity is when we just do the x value. X equals this or x equals that. That's a good question. Anything else? Cubic. Cubic. Okay. That's why I'm having it reflect yourself. No. This. Yeah. All right. That's why I'm figuring out to do it. That's right. Yes, you're transformations. This too, does it affect me horizontal or vertical? Okay, it's outside, it's not inside with the x, it's outside, so it's vertically. So it's vertical what? The one where it doesn't, the one where reciprocal is the special case. It's proportional. Right. So for our cubic, yes, and then 2, 4, 6, 8, 2, There are anchor points. So I'm going to start with 0. Vertical stretch factor of 2, 0. Translate down 5, so 1, 2, 3, 4, 5. There's my point. I might get a 1. Stretched by a factor of 2, so it gets multiplied by 2, the y. So this is 1, 1, the y value gets multiplied by 2, so now I'm at 1, 2, right? Then after I do that, I translate down 5, 1, 2, 3, 4, 5. And because it's true, and it's not reflection symmetry, it's rotational symmetry, but I can get this other point right there. Okay? Or you can count it if you're not sure what to do with that. Okay. My y value is 8. So my new y value becomes 16, right? And it's way up there. I'm 16, I'm going to translate down 5, so where do I actually end up? 11. 11 is reasonable to go off the graph. Try and graph like 16. But that can actually be helpful to you. It helps you get shape so that you are you're here instead of like way out here trying to get your shape. Make over here when I do this, negative 5 more, that's not worth even trying to figure out. It would be here's something that kind of helps you with the shape. Make sure that you make this straight because that is an inflection there, and it's hard to myself. Okay, so it's got like this is not have the points graph accurately, then you do your best attempt to get the graph look decent. Fine, okay. But sometimes with the points of inflection, you know, motion, if you just kind of get that part in first and then extend the rest, it'll make it a little bit easier for you. Okay, we all good? So it's been stretched and shifted. So our domain then, just like with the original, negative infinity to infinity. Range, negative infinity to infinity. Do you know what your x-intercept is? No, and it's not 1.25 or 1.5. Okay? We'll come back to that. Do you know exactly what your y-intercept is? Yes. So that one down, and then we'll talk about the other. Okay, 0, negative 5. All right, so I have to find my x-intercept. How do I find my x-intercept? 0 for what? Y. I set y equal to 0. Be very careful with the set the equation equal to 0, because what that means, f of x equals 2x cubed minus 5 equals 0. That's setting, this is the equation set equal to 0. That's not what you're doing. And if you're talking about this setting it equal to 0, that's not an equation, right? That's an expression. So what you are doing, and the reason some of you get mixed up, is because you don't know what you're doing with 0, right? You are looking for the x-intercept. The x-intercept is when y is 0. I heard some of you say, this represents my y. So 0 equals 2x cubed. Solve that. 5 equals 2 cubed. That means 5 halves. So x is equal to cube root of 5 halves. Okay. Can I leave it like that? No. You cannot have a cube, or you can't have a root in the denominator. So I've got cube root of 5 over the cube root of 2. What am I going to need to do? Yes. What am I doing? Rationalize the denominator. Remember when you did that, you sound all proper. It's really hard, right? But I'm rationalizing the denominator, and I need to add 2 more 2's. Why do I need to add 2 more 2's? Do you know what she means by that? As long as you know that you're not literally adding, but I know what you mean, and so that's fine. So that means that, do I multiply by the cube root of 2? No. Cube root of 4. This to be 8 down there, right? Cube root of 4 over the cube root of 4. Get the cube root of 20 over what? 2. Good job. And that's to my x. X then cube root of 20 over 2, 0. I have any extrema or critical points? Point of inflection. Are points of inflection funny? I didn't know. Point of. Algebra 2. Welcome to Algebra 2. Yeah. All right. Increasing intervals. Yes, the whole thing, right? So negative infinity to infinity. Infinity looks funky. And is it decreasing anywhere? No. So there's none. Then my end behavior as approaches back to approaches infinity. And then as x approaches negative infinity. Okay. Everybody good? Any questions? All right. Next page. All right. So this, what kind of function is this? Oh, leave it alone. The what? Square root. Yes. Finally. Okay. No, and I'll tell you what. So let me see your best. Talk about that. Okay. So it's and then yes, I started to like I go, I recorded it. There's a nursery rhyme. You poor deprived children. We're gonna sing I'm a little teapot one day. We just don't have time today. Okay. I know. Like, how do you not know that song? Come on. All right. So there's your square root. Some of y'all have been deprived. Your poor childhood. So square root. Then transformations. This is 3D. Good. It's a vertical stretch. So it's a vertical stretch. Factor of what? 3. It was on the inside, be horizontal. It's on the outside, so it's vertical. Right? Then reflect. In the y-axis. Good. Okay, so I'm done with all my multiplication. I got my 3 and my negative sign. If you have this stuff, you can graph down parent functions. If you're comfortable with your anchor, up here, start there. There's not 5 this time. There's 3. Okay, you need to have. And I transpose. Start at 0. This stretches and compressions don't matter because multiply by z when it's 0, 0. Then I'm going to reflect in the y-axis. That doesn't do anything either. And then I'm going to translate it right too. So that's really the only thing I end up doing with that point, just because it was at 0, 0. Then I go to 1, 1. Vertical stretch of 3 by 3. The y. So this now becomes 1, 3 instead of 1, 1. So that's 1, 2, 3. And then I'm supposed to reflect it in the y-axis. I translate right too. So I kind of reflected and came right back because of the nature of the numbers. Then I point at 4, 2. Vertical stretch by a factor of 3, which means now I'm at 4. Then from there, I reflect in the axis and end up over here. Right 2. Right there. Okay. And then I do the best I can with this. I'm trying to get the right angle and make my pen. There you go. That's not too terribly bad. Like that. So when I'm grading these, I'm looking for those anchor points being graphed, like regraphed, the new anchor points, basically. I'm looking for those to be accurate, and then your sketch to be, you know, an honest attempt at making it decent. Okay, but make sure I can actually see those points. That's important. All right. Well, I'm going from negative infinity to what? 2. Do I include 2? Yes, I do. And I just put a parenthesis there. Oh my goodness, that's big. Okay. Negative infinity, comma, 2. There we go. Okay. And then I start at 0 and go to infinity. Do I include 0? Yes, I do. Is 2, 0. I know what my y-intercept is. No, you do not. That would be a complete yes. Even if I mean, goes through that intercept doesn't mean anything. I didn't even not even accurate where I started. If you don't have an actual, you do not know where it is, and we can't figure it out from slope. So how do I figure out algebraically what my y-intercept is? Substitute 0 for x. So I'm finding 0. That's equal to 3 times the square root of negative 0 minus 2. It's right there. All right. What does that become? 3 squared root of 2. I do 3 squared root of 2 here. I do not put f of 0 here, so it's 0, comma 3 squared root of 2. Do I have any extrema? Yes. 2, 0, and it is an absolute min. Am I increasing anywhere? No? No. Am I decreasing? Yes. Negative infinity to 2. In behavior, as x approaches infinity, approaches nothing. Like, do I approach infinity? That make that negative infinity. And can I put something? Infinity. Talk about half of it. All right. Oh, G 0. Oh my gosh. Oh, right now. I can. Gx is equal to the root of x. All right. Oh no. Let me see your best cube. Yeah, kind of like this. Marianne, play along. Play along. It'll be a function. If you think you are, you're wrong. Christopher, let me see your question. No? Did you just tell me no? Fine. Good job. Okay. All right. Kind of like Walk Like an Egyptian. That was a song that actually somebody did record. That was the Bengals. Good job. Good job. All right. Transformations. That 2, what does that do? It's a horizontal what? Compression by a factor of 1/2. That didn't even look like it. 1/2. And then that's the multiplication, so the others are translations. So I'm going to translate. And what is so my anchor points: 0, my 1, 1, my negative 1, negative 1. Okay. Then my other point in the first quadrant, 8, 2, and that means over here it's negative 8. All right, so we're going to start with 0, 0. Compression doesn't do anything. Then I translate to the left 1 and up 1, 2, 3, 4. There's my new point. Then I'm going to go with 1. Okay? It's a horizontal compression of a factor of 1/2. So my x value multiplied by 1/2. I translate to the left one, which is negative 1/2. And then because of the symmetry, I can also get that one right there. I don't have to do that. Then I'm at 2, right? My horizontal compression, my x value gets multiplied by 1/2. So what's my x value now? 4. So I go to 4. Then from there, I'm going to translate to the left 1 and up 1, 2, 3, 4. Go ahead. So I'm here at -8, -2. My horizontal compression's 1/2, so my new x value is what? -4, right? And then from there, I translate and up 1, 2, 3, 4. Now, if I could turn my board, I'd turn my board because I feel like that I would be better at drawing this in if I was coming like down from the top instead of the side, especially with the pen. But I don't have that luxury, but that might help you. So I know I'm going to come in here. So let's something like that. Always better than whatever. My last point, I ended up at -5. 1, 2, 3, 4. It's -5. Yeah. Sorry. I thought it's at -5. All right. So then my domain, I'm going to infinity. The same as the parent. Do I have any x-intercepts? Yes. Do I know what they are right now? No. Do I have any y-intercepts? Yes. Do I know what they are right now? No. So I'm going to have to find both of these things. So to find the x-intercept, what do I do? So 0 equals the cube root of 2 times x plus 1 plus 4. Then I have to solve for x, right? So I'm going to subtract 4 from both sides, and I get -4 equals the cube root of 2 times x plus 1. So am I going to have to take the cube root of -4? No, what do? I cube both sides. So -4 cubed gives me a negative what? 64, good. And that's equal to 2 times x plus 1. Do I have to distribute that 2 in? No, I can, but I totally wouldn't. I can go ahead and divide and get -32 equals x plus 1. So what does x equal? -33. You know another place that big mistakes happen? Actually, they're little mistakes that are frustrating, but they happen a lot. That's what I mean by big mistakes. It's in a situation like this, where you just look at it and you're like, oh, all I have to do is divide by 2 and then add 1, and you end up with -31 because you were thinking through it quickly because it's easy, and you weren't paying attention, and then you make some ridiculous mistake that you totally know better. You with me on that? So I'm not saying, again, that you have to write every single step, but some of you need to write just a little bit more than what you do, and you'll kind of minimize it. So not only do we have 1, it's a pretty small number, but it's even a whole number. So -33, 0. Then I also have to find my y-intercept. So what do I do for that? 0 for x. So f of 0 equals the cube root of 2 times 0 plus 1 plus 4. What does that give me? Good. Cube root of 2 plus 4. Okay. So 0 and then cube root of 2 plus 4. You could write 4 plus the cube root of 2. That's the same thing. Roots are going to come first. Be very careful with the little sign that it doesn't hang over and you get sloppy and you can't tell what's underneath. Okay. We good? All right. Do I have any extrema or critical points? Yes. This end is at -1, 4. And that is point of inflection. Am I increasing anywhere? Yes, right? -infinity to infinity. And then decreasing none. my end behavior. As x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches negative infinity. Ooh, infinity 3. Okay. We all good so far? Any questions? All right, let's look at 6. So we've got this. What is this called? Reciprocal. It is a rational. I think I heard that, and I've heard that some. And it is a rational function. It's good that you recognize that. You need to know it's a rational. But rational is a very broad term, and then reciprocal is a little bit more specific. So this is the reciprocal. That means that g of x is equal to 1 over x. So looks like this. I won't make you do it. This one's a little harder, but there's a reciprocal, right? Yeah, you can do like little hands, like little crab hands or something. All right. So then I'm going to look at my transformations. Now, let's start with the negative. That's going to be a reflection, and I'm going to reflect in what? Does it really matter? Let me ask you that. No, it doesn't really matter either way. Since it's in the fraction, you can say technically it's affecting x, so it would be in the y-axis. But if we did it across the x-axis, it's fine as long as you don't use both. Because if you use both, you're just going to end up with the same thing you had to begin with, and that's not what you want. All right, so then I'm going to look at the rest of that. Now, you can look at this a few different ways. Here's what I think. I think it's good to be consistent. I think it's good to do what makes the most sense when you kind of see it. I can force this into being a horizontal something with the 4. However, I think most of you would probably easier right there. Yeah, and remember, for the reciprocal and the reciprocal only, whether you do horizontal or vertical, it does not matter. So instead of trying to force that into a fraction in the denominator to make it horizontal, don't worry about that. If I can look at it like this, and that gives me the same thing, now that 4 represents the a, which means really we're looking at this as what? A vertical. So we can say this is a vertical stretch, and the factor is 4. But remember, for reciprocals, I'm going to put a little star here because we're going to use it. That means that I could also, if I did a vertical stretch of a factor of 4 and Alex graphed it and he did a horizontal stretch of a factor of 4, we'll have the same graph in the end. You just can't, again, you can't do both, but you do one or the other and it's fine. Yes, it would be a stretch. It would still be a stretch and the number would be the same because the way to change this is this would be 1 over 1/4. So you'd have that 1/4 multiplied down there. And then when you take the reciprocal of the 1/4, you get the 4 for the horizontal. That's why they end up being the same. All right, and then that 3 means I'm going to have translate what? Left 3. Okay, so with these, we usually save the translations to left. When you have asymptotes, that's something that you have to look at first, okay? So I have 2 asymptotes right here, and we only had 2 anchor points, right? So let's go ahead and put our anchor points on here. They were just here and here. And I'm not going to draw the original asymptotes because I think that would just make too many things be too confusing. But when you translate it, the asymptotes have to go with you. You stretching and compressing them doesn't do anything. But I'm going to translate left 3. So I had an asymptote that was on the y-axis. It's now going to be at x equals negative 3 because it got translated to the left 3. The horizontal one doesn't move because there wasn't any sort of vertical translation. Okay, everybody good with that? So we started here with that, and then we'll come back to the actual points, but you got to get your asymptotes in there. All right, so here's how this is going to work. We take this point. We only have 2 anchor points. I'm going to do this. I'm going to reflect it in the y-axis. Boom, it ends up right there. And it's a vertical stretch by a factor of 4, which means what gets multiplied by 4? The y-axis. So I actually end up at negative 4. Translate to the left 3, and I end up right there. Everybody with me? So to get another point over there, I'm going to go back to this original point, And this time I'm going to do the horizontal stretch. So I'm going to do everything else the same. Back to my same original point. I'm going to reflect it in the y-axis. A horizontal stretch of a factor of 4. So this will be at -4, 1, right? And then I translate it to the left 3. That's another point on my graph. And those 2 points right there help me get that shape. Okay, that's why I put a star here, because we put vertical, but we could have put horizontal. You do them both, but you don't do them both at the same point, at the same time. Like it ends up giving you 2 different points. So I want you to try that with this anchor point right here. And then I'm gonna pass out while you're doing that, and we'll talk about it in a minute. And then I'm gonna pass out some progress reports.